Welcome back. We are going to look at the trends of properties of element 2. We have talked about the ionization energy, electron affinity, and electronegativity. We are going to look at this topic. The topic for today's lesson is trends of properties of elements in the periodic table 2, atomic and ionic radii, electrical and thermal conductivity, melting and boiling points. Specific objectives. At the end of the lesson, students should be able to 1. Define atomic and ionic radii. 2. Explain how atomic and ionic radii vary along the period and the group. 3. Define electric and thermal conductivity of the atom. And 4. Explain how electric and thermal conductivity, as well as melting and boiling points, vary along the period and group of the periodic table. Atomic radius. The radius of an atom is the distance between the center of the nucleus and the outermost electronic shell. Generally, atomic radius decreases from left to right across a period. This is due to the steady increase in nuclear charge. That is the number of protons in the nucleus. Now, listen. As we move across the period, the number of shells, as we move across the period, the atomic number increases. But when you move down the group, you discover that the number of shells increases. And as the number of shells increases, the atomic size increases. And if there is increase in the atomic size of the atom, automatically there will be increase in the atomic radius. Atomic radius increases steadily down the group due to increase in the number of shells. I have said it. If you watch in group 1, we have hydrogen. In the second group, we have lithium. Hydrogen has 1 shell. Lithium has 2 shells. If you move down lithium, you see sodium. Sodium has 3 shells. So as you are moving down the group, in group 1, the atomic shells increases. And that brings about increase in atomic size. And that also makes the atomic radius of the atom to increase automatically. On going down a group, the screen effect becomes stronger than the attractive force exerted by the positive nucleus on the valence electrons. Hence, the size of the atoms increases as you go down a group. Ionic radius. Cations are formed when atoms of metals lose electrons, while anions are formed when atoms of nonmetals gain electrons. The radius of a cation is always smaller than that of the atom it was derived from. Let's take it again. The radius of a cation is always smaller than that of the atom it was derived from. A cation has 1 less electron shell than its atom. On the other hand, an anion is always larger than the atom which it is derived from. The ionic radii for both cations and anions decrease down a group and increases across the period. Yes. You know that a cation is formed when a metal loses electron. Of course, what is a cation? A cation is simply a positively charged ion, and an anion is simply a negatively charged ion. So for a cation to be formed, a metal must lose electron. Now, take for instance sodium that has atomic number of 11. In the first shell, it has 2. Second shell, it has 8, making it 10. The third shell, how many will it have? 1. Fine. the third shell will contain only one electron. That is for sodium atom. Now, if that same sodium atom forms an ion by losing an electron, which is in the valence shell, what's the number of electrons that will remain? 10. You can see that it has reduced the 3 shells of sodium atom to 2 shells, because it has lost 1 electron. So it has lost 1 electron, the number of shells has now reduced to 2. So that has to agree with the fact that the radius of a cation is always smaller than that of the atom it was derived from. Because the radius of an ion that has 3 shells and the radius of a sodium atom that has 2 shells, which one will have larger radius? Of course, it is the sodium ion, because it has 3 shells, but the sodium atom has only 2 shells. So there will be a reduction in the radius simply because the number of shells has reduced. So as we go down the group, as we said earlier on, that the ionic radii for both cation and anion increases, whereas as you go across the period, the ionic radius for both cations and anions decreases across the period. Now, for the anion, an anion is formed when a nonmetal accepts electron. When a nonmetal accepts electron, there is increase in oxidation number. Take for instance sodium. Sodium atom has atomic number of 17, whereas sodium ion will be 18. You can see that there is increase in oxidation, there is increase in atomic number because it has accepted 1 electron. So for non-metals, they form anions, and as you go down the group, the atomic radius increases and decreases as you go across the period. The radius of a cation, sodium has first shell 2, second shell 8, and third shell 1. So after losing an electron, it will have first shell 2, second shell 2. You can see that in the product side, sodium ion has no third shell, but when it was sodium atom, it has 3 shells. So there is a reduction in the number of shells. Therefore, for radius of anion, chlorine atom gains electron. You see that the atomic number here is 17, first shell 2, second shell 8, and third shell 7. After gaining an electron, there will be increase in oxidation number from 17 to 18. And this configuration will now be first shell 2, second shell 8, and third shell 8. Evaluation. Define atomic radius. 2. Define ionic radius. 3. Explain how atomic radius varies across the periodic table. 4. Explain how ionic radius varies across the periodic table. All right, let's solve it together. Number 1. Atomic radius is defined as the distance between the center of the nucleus and the outermost electronic shell. Ionic radius is defined as the distance between the center of the nucleus of a cation and the outermost electronic shell. Number 3, atomic radius increases down the group but decreases across the period. And number 4, ionic radius increases down the group but decreases across the period. All right, we've come to the end of this lesson. Thank you for listening. I hope you enjoyed my lesson. See you in the next class. Bye.